Hello, this is Magnus, and today we are going to do a question from the Vector Resolution Worksheet that we received in Physics 12 a while back. A dog's owner walks 20 meters west, then turns and walks 150 meters west, 34 degrees north, and finally 655 meters north, 77 degrees east. Use the component vector method to find the dog's displacement. So let's draw our vectors. So we are going to have a vector. This is going to be our crosshair. This is where our dog owner is going to start. We're going to go 20 meters west. And I apologize in advance. First video, me getting used to drawing on a draw tablet for my computer. So just avoid that. Okay. Then turns and walks at 150 meters west, 34 degrees north. So over here, this is west. Of course, this is north. Over here is east. Down here is south. So west, 34 degrees north. That means that from this point, from west, we're going to turn 34 degrees upwards. So that means that we're going to go at an angle like so. This is going to be 150 meters. So we know this angle is 34 degrees. We need to know this angle for later. So 180, which is the degrees from our 0 degrees to our west, minus 34 degrees, is equal to 146 degrees. And you'll see why this is important later on. Okay, finally, we go 655 meters north, 77 degrees east. So we know up is north, and from north we go 77 degrees east. So we're going to have a very shallow angle. Just give me a second here. Going for a very long line. This is 600. Actually, no, I'm going to get rid of that. There we go. 655 meters. Okay, so we know this angle is 77 degrees, but we want to know what the angle is with our 0 degrees. So 90 degrees minus 77 degrees gives us 13 degrees. So I know what, that this angle theta is equal to 13 degrees. Oh, sorry, technical issues. No? Oh, you don't like me drawing angles? You're gonna let me draw? Oh. Okay, what's going on? Why is it? Okay.
Okay, I can cut this part of the video out. Just go to the top, click draw. Select your color, then it should let the draw again.
Okay. Thank you for our tech support. Okay. So, this is 13. Wow. And there goes our vector. Fun. Okay, this is 13 degrees. No, we're going to do this until we get used to this. There, 13 degrees. So, we have to use the component vector method to find the dog's displacement. Now we know that the final displacement is going to be equal to the resultant. All the resultant is where you started versus where you ended up. So this line will be your resultant. But we want to find out what this distance is. To do so, we will use the component vector method. And all the component vector method is for any vector, like so, we use trigonometry to find its x component and its y component. If you know this length right here, I'll just put that as, I don't know, r as a vector. To find, actually wait, no, that is not correct. Okay, sorry. Yeah, to find its x component, you do resultant cos theta. To find its y, we do resultant sine theta. Theta being the angle it is relative to 0 degrees, or your east, and r being the length of your vector. Just as a side note, if you ever get questions that give you something in meters, then gives you another vector in something other than meters, you'll probably have to do a side calculation to make sure all your vectors are the same units. Another question on the same sheet follows suit in this. So, we're going to use the component vector method to do this. So we are going to go down a little bit. Again, I'm a little disorganized first video. I'm just going to put vector. Then I'm going to put, we'll go y, and then we'll go x. Whoa. Again, first video. I will get used to this one day. Okay, so our first vector is 20.0 meters at, you know, this is 0, so 0 to our west is 180 degrees. So this would be 20 meters at 180 degrees. Okay. Actually, no, what am I doing? Sorry. No. There we go. So, to find the y, we would take our 20.0 meters, and we would take the sine of theta, which is 180 degrees. And we know that anything sine 180 degrees is equal to 0. So 20 times sine 180, or times 0, is just going to be equal to 0. Now for x, 20.0 meters, no, cos 180 degrees. But we know that anything cos 180 degrees is -1. So it's going to be 20 times -1, so this will be -20 meters. That is our first vector. 2 more to go. So our second vector is 150 meters at this angle we calculated earlier, so 146 degrees. So to find our y, we do 150 meters, and we take the sine of its angle relative to 0 degrees or east, which is sine 140 degrees, and this equals approximately 83.87 meters. Again, you can do these calculations on your own if you want. To find our x, we do 150 meters. Take the cosine of 140 degrees. Now, and 150 cosine 146 degrees is negative 124.356 meters. Sorry, I'm kind of getting closer to the edge of the screen there. Get our meters in there somehow. Again, I apologize for this video. Okay, now we have our final vector, which is 655 meters at this angle we calculated up here, 13 degrees. At 13 degrees. To find our y component, we do 655 meters times the sine of 13 degrees. This equals approximately 147.34 meters. Same as above, x component 655 meters times the cosine of 13 degrees. This equals approximately 638.21 meters. And just to verify these, again, it's not asking for a scale diagram, so of course mine is very shabby, writing on tablet for first time, which is connected to my computer. But anyway, you're going 20 meters west, so you're not going up and down, so y should be 0, and you should have all of your vector as x. You're going left, which is a negative direction with vectors, so you do get negative 20 meters. We go upwards at an angle of 140 degrees, so we should have a positive y, because it's going up, and negative x, which we do. Final vector is only 13 degrees above the horizontal, which means most of it should be x, which is true, and a part of it is y. So now what we are going to do is we're going to take these vectors and we're going to make a net. So we want our net y and x vector. So I'm just going to isolate this from everything else so it's a little easier to see because I'm messy. So I'm going to have y, I'm going to have x. There we go. So we have 0, no, that's not how I'm going to put it. Sorry everyone. We are going to have 0.000 meters plus 83.879 meters plus 147.340 meters. That will give us an approximate net y of 231.219 meters. For our x, we have negative 20.000 meters, and we minus 124.356 meters plus 638.210 meters. I just added extra decimal places so things line up. And this will give us a net x of 493.854. Again, these are both positive values. And you might be wondering, what did I just calculate? So all you calculated is this resultant. You found out how far in the x direction this has traveled after all this movement is done, and how far it has traveled in the y direction in all these vectors. Why is this important? Well, this conveniently makes a right angle triangle. And if we know this side as our, oh, what am I doing? If we know this side is our x, and this side is our y, then what can we use to find this hypotenuse? We can use Pythagorean's theorem. So, I'm going to go down, and I'm going to draw a right angle triangle, which we're going to use for reference. So this is going to be our resultant. This is going to be 493.854 meters. This is going to be 231.219 meters. So, I'm just going to draw this so I have a little more room. So, Pythagorean's theorem, you know, is c squared equals a squared plus b squared, shortened version of Coase law. But instead of c, we're going to punch in our resultant, because that is what we're using. So, resultant, make sure you add the arrow on top, it is a vector. So our a, I'm going to use my x as just my a to make it simpler for me. So we have 493.854 meters squared plus my y, 231.219 meters. And this is squared. Resultant is going to be equal to the square root. I just took the square root of both sides. This is going to be equal to, okay, 243,891.77 meters squared plus 53,462.23. Just leave me on some decimal values so it's a little smaller and I don't go off my screen. Resultant is going to be equal, oh, mistake on my part, I apologize. Resultant, not squared, is equal to the square root of whatever these two terms add up to, which is 297,353.993 approximately. And again, you can do all these by yourself or pump it into vector calculator, check my answers afterwards, whatever. And our resultant is going to equal approximately 545 meters. The only reason I rounded to here is because if we go up in this question, this has 3 significant digits. You might say this has 2, but there was a period right here in the question, which makes this 3 significant digits. And 655, that is 3 significant digits. So, we have 545. And I just kept in decimal values while doing sine and cos because just so we're slightly more accurate. So now that we know the length of resultant, which is 545 meters, we now want to know the angle theta that our dog has gone at, because we already know that this is 545 meters, but because it's a vector, we need to include an angle. So let's calculate the angle. And to do this, we're going to use probably the most powerful of the 3 right angle triangle trig ratios. That is going to be the tan ratio. So tan of theta is equal to opposite over adjacent. Oh, I forgot to label my sides. So the longest side of a triangle, or the one across from the right angle in a right angle triangle, this is going to be your hypotenuse. This is our reference angle. The side opposite of the reference angle is our opposite, and the one side that's left over, which is next to your reference angle, is your adjacent. So we're going to manipulate this formula. We know that tan theta equals opposite over adjacent is the same thing as taking the arctangent, or tan to the negative 1, of opposite over adjacent. Okay, so theta equals the arctangent of our opposite, which is 231.219 meters over 493.854 meters. Okay, theta is equal to the arctangent. Let's see. This is going to be 0.46819. And again, meters cancels, so don't have to worry about units. Plus, it's going to be an angle. So when we take the arctangent of this is going to be equal to approximately 25 degrees. So, to put it all together, the resultant, or the dog's displacement, is equal to 545 meters at 25 degrees. Oh, degrees. And this is correct because this is from the horizontal up, so we don't have to worry about some kind of, like, sometimes if you find the triangle in a different quadrant, you'd have to do math to find your actual angle in reference to east, or 0 degrees. But in this case, it's already based off of east, because east is one of the sides. Again, well, that's not entirely true. If it was opposite, you'd have to do 360 minus your angle. But anyway, this is the answer to number 7. If you pump this into a vector calculator, you might get slightly more accurate results. You know, they don't necessarily take significant digits into account. But this is the answer I got, and I know many of you have gotten as well. Hopefully this clears up any confusion with the component vector method, or just this worksheet in general. I know this one was only 3 vectors. I know number 9 was 5, so a lot more calculations, but maybe I can do that one at a later date. I hope you all enjoyed and that this helped you just to understand physics more. Anyway, have a good rest of your evening, I guess. For me, it's evening. You might watch this tomorrow morning, but you take care, and hopefully I'll make a video soon. See ya!